So in this last video, we'll make sure that we know how to use our equation to help us figure out questions B and C. Question letter B says, how much money will they have in the jar after 10 weeks of saving? Now you have two options, just as we've talked about throughout this lesson. One option is to just continue the table. If you've already made a table, or if it's easy for you to see the pattern, you could just keep counting week 5, week 6, week 7, week 8, week 9, week 10, and just extend the table by adding 6, adding 6, adding 6, adding 6, adding 6 until you need to stop, and that would tell you how much money they have in the jar. If you want to use the equation, that's another option, because in the previous video we wrote an equation for this situation, and we could use the equation as long as we remember that n is the number of weeks that we're dealing with. And we've talked about this before, the idea that if n is the number of weeks and 10 is a number of weeks, we can just substitute the number 10 in the equation where the letter n is, and we can just figure this out. So that means if I substitute 10 for n, I would have 5 plus 6 times, instead of n, 10. And that looks like math that I might not even have to use a calculator for. That's 5 plus 6 times 10 is 60, and 5 plus 60 must be 65. And that makes sense, because if I'm adding, then by the time I get to 10 weeks, seeing the pattern emerge in the table, 65 bucks sounds right. It's not a crazy big amount of money, but it certainly seems like it fits the pattern that we've seen so far. So the equation made things a lot easier, and sometimes the equation is more efficient than the table, but some people are really good at making tables and doing patterns fast, so it's kind of up to you to decide which way is best for you. Now in question letter C says, they'll take their dream vacation once the savings in the jar reaches $1,000. How long will it take them to reach this goal? Now this I want to think about, because 1,000 is a number of dollars. I can't plug 1,000 in for n, because n is a number of weeks. If I go back and I look back at my equation, I remember when I set up my table, n was the number of weeks, and t of n was a number of dollars. So I'm looking back at this, n is a number of weeks, t of n, and I'll label it here, that's a dollar amount. So if I want to use this 1,000 in my equation, I should use it where t of n is, because t of n is a number of dollars. So I'll copy my equation, but instead of t of n, I'll put 1,000 equals 5 plus 6, and since we don't know how long it will take, in fact that's what the question's asking, I'll just put the letter n to show a variable. We don't know how long it will take, so I'll use the variable there to say we don't know. As I look at that problem, I'm naturally seeing it as an algebra problem. I want to get n by itself. So let's think about how we can use our algebra skills to help us get n by itself. One option, of course, is to get rid of this 5, moving it to the other side, subtracting it, if you will. So 1,000 minus 5 would be 995 equals, and then since the 5's canceled, 6n. Now if I want to get n by itself, I'd need to get rid of the 6. The 6 is multiplying, so I'll divide by 6 on both sides. And I'll grab a calculator because it doesn't look like that will be a very nice answer. 995 divided by 6, yep, sure enough, is kind of ugly. 165.8333, and so on. Now, this is a number of weeks, so if you think about it logically, 165.83 weeks is possible, but nobody really measures weeks with decimals. So you could say, just to be reasonable, that it takes approximately 165 weeks. Some people would argue that it's 166 weeks. They would argue that you should be rounding up. You can decide whatever you want to put. You could put exactly 165.83. You could put approximately 165 or approximately 166. When it comes to tests and quizzes and things like that, you'll be able to use approximate answers and you'll be given credit for any approximate answer as long as it's in the ballpark. Now again, that makes sense, because if they started out with only $5 and if they're only saving $6 a week, it is going to take a long time for them to reach $1,000. So 165 weeks, if you think about that roughly, that's basically about 3 years, because there's 52 weeks in a year. So yeah, if you were only saving a little bit each week and you started out with only a little bit initially invested, it is going to take you a few years to finally reach your goal. So it is always good, as I've said before, to think about this in terms of common sense. If this was your real life, would that answer make sense? And it does. If you're saving only small little chunks of money, then it is going to take you a long time to save a big number like $1,000. In any case, hopefully now you've gotten a little bit more comfortable with the idea of word style questions. I know that sometimes when people see word problems, they assume they're going to be really hard and they assume that they can't do them. So hopefully this lesson and the page before it gave you a bit more confidence that these are a little bit more predictable. Once you have equations to work with, it's just lots of plugging in and calculator work. If you have questions, or if there were any problems that didn't make sense in these videos, please don't hesitate to either email me or pop into the Zoom hours and ask about any questions that you may have.